Alright, DraftScience video. Hopefully this camera will hold out. This is probably going to be a long one. Probably do it in parts to finish it. But anyway, I think it's going to be useful. So anyway, somebody posted me to some Google group on physics. And, you know, it was only a group with 115 members or something, and it didn't look too active. So anyway, I did a search on this group thing, and there's a ton of physics groups. So I figure I will post messages to them, and I'll just go in the order as they're presented, because Google doesn't let you search, and it's just really irritating. So anyway, this one's called Physics. There's 44,000 members, and some of the content is interesting, little experiments here and stuff. So I did post a post, no response to it. Kind of disappointing. It's, you know, 13 hours, you know, nothing. So if you want to write some paragraph of text, how you would introduce yourself or provoke conversation or whatever, this is what I wrote. Looking for some rebuttals to my debunking of the evidence used to defend wave theory. I basically claim there are too many hard conclusions being drawn on soft evidence, and would like to do some video exchanges on subjects like the two-slit if anyone is willing. I just think you ought to be able to argue physics in videos. I mean, this really should be possible. Anyway, but any on-subject commentary would be appreciated. Probably should have put a warning about some foul language, because yes, the video does contain a few skanky cunts and whatnots. Anyway, so I'll do that next time. But I figure I'll make a daily post to a room per day and see how this goes. So far, so bad, though. But the interesting thing was some guy is posting these lectures that are on Vimeo. So, haven't seen this before. They're kind of for dummies version, sort of. But I mean, it's real physics. It's just kind of taught in a slow and tedious manner. But it just gets to all these concepts, and that's the really important part. And so I think this would be quite useful to point out where, you know, there's lots of these crossroads. You can go right and go left. You know, for light's a wave, light's a particle. Those kind of questions. Lots of those questions out there. You know, gravity. Is it attraction or is it a force of push or pull? And sort of what I've been arguing is that it just ironically, maybe, or just for some reason, it seems every time physics has one of those choices, they've chosen poorly. They just got it wrong, and so they have these wrong premises and you know, these axioms, and it just destroys the logic of their physics. And but it's a very subtle thing. It's almost semantics, but it's kind of important semantics. What is an actual thing? What you're calling space? You know, there's no real point in calling space, the space between atoms, let's say, a field, because then it's not space anymore. It's field. If you get my drift, it's just kind of breaks the idea of empty space if you're going to put a grid work of some mechanical structure that moves at the speed of light. You know, ironically. You know, again, it's not ironic. It's one of those choices. Maxwell had a choice. He could understand force moving the speed of light, and he could say, hey, isn't it interesting that forces are moving the same speed as light? And instead he said, whoa, light's moving the same speed as forces, therefore light must have electromagnetic character. Nah, just a huge mistake. But anyway, let's on to the show and such, and we'll see how it goes.
We are halfway through our course on gravity. It's a turning point in the story. Here's that story so far. Gravity is a force, part of Newtonian mechanics.
Right, okay. It's very nice to use the word force, but if the force has no identity, has no substance, has no mechanism, then you're not doing what I think physics is supposed to be doing, which is explaining the physical cause and effect reasons things happen. To just say force is nice, but it doesn't say anything about what, why, how, just doesn't answer the question.
And gravity has some special properties.
Well, obviously it has properties. That's why we call it gravity. We don't call it Jell-O pudding, right?
It's very weak compared to other fundamental forces of nature.
Right. Well, the whole weakness argument is it's the most dense, okay, of the field energy, I would argue. So, I mean, by my understanding, it's this simple. Everything, all the forces are one thing. There are these quanta moving the speed of light. The gravity has neither frequency nor, and it has random polarization. So, light has frequency and polarization, and magnetism is polarization. So these things filtered out of that field. So light is only a tiny part of gravity, yet light's impact on matter is more significant than gravity's impact, because most of the gravity travels through the matter benignly, because most of the polarization of the gravity the matter is not sensitive to. So that's the key to this thing. Matter has a sensitivity polarization based on its orientation. So an atom's orientation will dictate its sensitivity to the environment. So, but the gravity itself as a force is much more dense and therefore much more powerful as total energy than the other forces. It's just that the other forces, matter is more sensitive to. Specific polarization and specific frequency.
It is an attractive force between masses.
Okay,
and
so
it is a universal force.
So this is one of those things, attractive forces. So this is a conclusion. I think they just chose one. They're calling it a pull force. They're saying somehow the thing radiates the force then impacts the thing to be attracted in some mechanism like that, and it's just fundamentally incorrect. It's a push mechanism, I would argue. I say the evidence indicates push is more physically describable, it's simpler, it's a simple physical mechanism, pushing. Pulling requires more complexity. It requires some sort of hook. You have to hook into something before you can pull it. You have to grab it. You don't have to grab to push. Lots of reasons, logical reasons like that, deductive type reasons, to go with push rather than pull as something that would be in the foundation of the physics. What else do I want to say about that? Well, I might as well get to the point. This is it's a pressure thing. So the fields exist only as something active. They're creating pressure. They're creating a kind of light. So gravity, if you thought of gravity as being light, turn off the regular lights in the universe, turn off the sun radiating photons that we can see, and then turn on the light of gravity, then you could see what's really happening, which is the gravity is a consequence of proximity, and as things get close to each other, they start shielding part of the light produced by the universe, and that shield is revealed as a shadow. So if you saw then in this bright universe, if you recognize that the dark patches where this attraction thing is going to happen, you can then just do it more explicitly and say, if you understand that to be pressure, you understand that there's a low pressure between them in a straight line force, a force that can't bend around the corner. So if it can't move, the pressure can't be balanced, it can't find equilibrium by going in a crooked line, which force can't do. Forces are straight lines. Yeah, you have a shadow. You have low pressure, and things acquire velocity and acceleration in that circumstance. They absorb it. Universal force, well, yes, I guess so.
Force. That is, every mass exerts gravitational attraction on every other in exactly the same way.
Right. So it's obviously the simple point is that if there was rain, you'd say the rain falls on everybody the same. Yes. None of us exert anything. We block something. We get in the way of something being exerted. We don't exert anything. We don't pull anything towards us. We don't radiate anything. We block radiation. Little factoid. Well, I'll get to it later because it's not, there's so many of these things I just want to say, get it done with, get to the E equals mc squared thing, get it to the idea that, it's this whole speed of light thing, this whole Einstein thing is so wrong in terms of how they're thinking about it. They're thinking about, like, him as a piece of matter riding on a photon, let's say. If you just thought about that for a second, just thought about the fact that you have atoms inside of you, and even the standard model is conceding that there's moving parts in those atoms. Well, how could I move the speed of light? Because then the pieces inside of me, some of them would end up going faster than the speed of light because they'd be going the same way as my movement. And that can't happen. So then you can understand there's got to be something that dampens that, something that compensates for that, like that piece would move across my matter or something, or some other kind of mechanism. And the real mechanism is just dimensionality. A photon only has mass in one dimension. The dimension's moving. If you start moving the speed of light, you lose your perpendicular dimensions. You don't have them anymore. You don't have bits moving this way and this way, or this way and this way when you're going that way, the speed of light. You have no material substance in these perpendicular dimensions anymore. That's the time dilation. That's the loss of your material form. Being material means having radiating bits. You have pieces inside of you moving in every single direction. That's what gives you three-dimensional material form, is that you actually have bits moving in all these directions. And the faster I move you, the less bits you're going to have in any of those perpendicular dimensions to your velocity. I think it's a fact. I think that's the rational way to understand the momentum argument. Your bits are the things that are moving. They're all moving the speed of light. You can't really go faster. Your bits can't. All you can do is exchange one's going the way you're going for one's not going the way you're going. And that's it. It's a school of fish. It goes the direction the fish are going. You have to have more fish going that way for the school of fish to go that way. Fact.
The strength of the gravitational force decreases with distance. It is proportional to 1 over the distance squared.
Yeah, I don't know why they don't do this more clearly. It's proportional to, there's no distance. I mean, there's no, the constant, I guess, is the small g. So, but yeah, it's a little bit, and it really just doesn't explain that there's two bodies involved. The one body is creating a shadow on the other body is creating a shadow on it. The two aren't doing it universally. So the distance argument, in some respects, they usually do the M1, M2 thing here, combining the masses. And that's kind of dangerous because the two forces are affecting each other differently. There's a different amount of shadow. What else do I want to say about that? There was something else important, but the fact that this rule applies to all of the Maxwell stuff, the electric and the magnetic, that the other forces are moving at the speed of light, and they're doing it just like this. This is the definition of a straight line force. That's what this is telling you. That like a light bulb, the light is coming out in straight rays. That's what the forces are all doing. They work just like this light bulb. The further away I get from the light bulb, by the same rule, it gets dimmer. My hand, half the distance, 4 times bigger. That's the rule. It's because light's a straight line force. That's why this happens. Okay.
We've seen lots of phenomena that are governed by gravity, both everyday phenomena on Earth and also exotic phenomena in deep space.
All right, well,
We have also found that gravity phenomena that are governed by gravity.
Let me go back and
both
just
everyday phenomena
use this
on Earth.
picture to my advantage here. So what's happening with this apple, right? Now if I took an apple and I put it in the middle of space, okay, so that it has no gravity that's obvious, no strong gravity affecting it, it's not moving. The truth is, that's when it's moving the most. That's when it's at its maximum speed in a way, because it has maximum pressure. That is, if you thought of the universe as lights on, when gravity's the heaviest, it's the brightest. So it's in the bright area. And what it's really doing is it's accelerating in all directions all the time. So it's constantly Brownian motion moving. And they have connected evidence, again, in the other forces, because it's understood that the velocity of electrons in a wire, for example, that actually when you start moving the electrons, they move slower when you apply the voltage than they're moving when they're at their rest state. So the rest state is a higher velocity, and it's a higher velocity because they're doing this. They're moving in all the field directions, in all the dimensions. They're being accelerated a little bit, and they're accelerated the other way, and they're accelerated, and it has an equilibrium because it's an equal force, a balanced force. And so there's no going one way. There's no getting out of that circle of motion. But technically that's when there's the most field pressure and the most acceleration. And it's when you're shadowed that you lose acceleration. So think of the apple in empty space. It's got the maximum amount of velocity in all directions, acceleration in all directions. And when I put something shadowing the force coming this way, I'm slowing down the acceleration, going opposing the acceleration this way. So now it's accelerating down, not because this pressure increased up here. This pressure didn't increase. No, it's just that the pressure, the balance is now broken. There's no longer equilibrium, and now the apple falls because there's less it has less acceleration this way because the Earth actually absorbed the acceleration. The Earth took the acceleration from the gravitational field, it accelerated, and now the apple can't. It's used up. It's slowed down inside the Earth, accelerating the Earth. And so now it can't accelerate the apple, and the apple falls. So this is really the apple slowing down. Even though it's speeding up in one direction, it's overall losing velocity. It's losing acceleration. It's accelerating less when it's accelerating in one direction, because that's really decelerating in the opposite direction. It's decelerating going this way because there's less accelerant pushing it. Less accelerant, it's got too much accelerant on top. Clearly just a pressure argument.
Earth, and also exotic phenomena in deep space.
Alright, so we're using synthetic photos. I don't think there's much point in that.
We have also found that gravity lets us see things in the universe that would be otherwise invisible.
Alright, so that's a little bit messy. We can't see, we can just see things moving. So I don't know how we could see them without seeing them move. And so I don't know how gravity makes that. I don't get it.
You can see planets around other stars, or dark matter in galaxies.
Well, it seems obvious that the planets wouldn't be orbiting the other stars if there was no gravity, so yeah, but maybe we would see them shooting across space then, so I don't know how the gravity helps us see them. That's still kind of mushy language. Just a technical point.
Our turning point is a revolutionary new point of view about space, time, motion and gravitation.
Well, let's understand it's not revolutionary anymore. It's 100 years old, and it was wrong then, and it's wrong now, and it's just not a very good way to you know, deify it, to whatever the right word is for making this religion a fact. It's a mistake.
Developed by Albert Einstein, beginning about 1905. These ideas and their implications.
Alright, so let's understand, when Einstein's talking about space, then space, warp space, all this kind of crap, it's not really space. He's talking about a field. So he's talking about a grid work of some kind, a mechanism, a superstructure that is conveying the existence of one thing to the existence of another thing. And it just happens that it does that conveying at exactly the speed of light. So the magnetic field, the structure, somehow things wave across it at exactly the speed of light. You know, I mean, I think clearly it's not doing that. The thing is an actual thing. Light isn't moving through a field. There's not a field of electromagnetism, the magnetic field going this way and the electric field going this way, and light is waving through both of those fields, these grid works, this superstructure of mechanical stuff. No, it's a thing. It's moving the speed of light, and when it shows up and when it hits an electron, it lets you know I'm a thing. I've just interacted. I can cause an electron to accelerate. I'm not a wave, I'm a thing. And I'm a thing that your matter is made of right now. Your matter is made of those very things, little bits moving the speed of light.
Will be our main business for the...
So just understand, space isn't really, he's not talking about empty space. He's not talking about the empty space between two atoms or some other thing. He's talking about the space having a fabric. It actually has some kind of real mechanical structure that conveys information, force, from one thing to another across that mechanism, that grid work, that trellis, that thing. So space isn't space. Time is just a function. So this one is just simple. Time is what it takes. It takes the fastest thing known, okay, the speed of light, to go a certain distance. You automatically have the function of time when you have something that doesn't happen instantaneously. So we know that force doesn't move instantaneously, light doesn't move instantaneously, it doesn't arrive at my eye instantaneously, it doesn't leave the camera, move to my eye instantaneously, nothing happens instantaneously, these forces don't move that way. That creates time. So time is just about the fact that there's not instantaneous motion. So the end. It's not a dimension, it's a function. And as long as there's a constant, the speed of light, time never fluctuates. You can either run slow or you can run fast, but you can't change time. I mean run you as matter. You can change the disposition of your matter. You can convert it from three-dimensional matter, equal in all three dimensions, and you can gain velocity, which means you have more mass in one dimension and less mass in the other two dimensions. That's what you can do. You can lose your dimensionality, but you can't warp time.
Rest of the course. Like Einstein, we first must lay some groundwork.
Well, like I said, you're not laying groundwork. Einstein didn't lay groundwork. He stated axioms. He chose. He decided that a photon has mass as matter has mass, that it's somehow three-dimensional mass, and that you can affect it in these perpendicular dimensions, that you can push it somewhere. You can mess with its course by blowing on it and push it. You can't. It doesn't have any perpendicular dimension. It only has mass in the dimension it's traveling. You can't bend it. He's chosen that. He axiomized it, and then you all fell for it based on his best friend validating it by, you know, putting on a pair of sunglasses and looking at it in the lips. I'm not saying the science was that bad, but I mean, it was a pretty pitiful experiment. It's never been duplicated. The Hubble telescope's never done it. You have no evidence of solar lensing, of the sun lensing. None. No good evidence. And yet you're telling me this is a fact. Einstein proved. No, Einstein said it. And you're just telling me Einstein said it. That's all you're doing. You don't have any evidence that it's true.
And occasionally, it may seem that we've wandered away from the topic of gravity. Well,
yeah, you've wandered away from the topic of physics, in my opinion. You will wander, eventually.
Talk about the speed of light, about clocks and time, and so on. What do these things have to do with gravity?
Yeah, well, the only way they have anything to do with gravity is understanding this dimensional issue. Again, this is just fundamental to it. If you don't understand that matter has mass in 3 dimensions because you have force in 3 dimensions, and that if I was to go with the speed of light, I would no longer have force in 2 of those dimensions. I would only have force in the 1 dimension. Anyway.
Well, what we're doing is we're building a foundation. In the lectures to come, we will need every part of that foundation to build our new understanding.
Right, and if you make a mistake in that foundation, it could end up meaning Tower of Pisa problem. Yes, you can build something that might look like a building, but you wouldn't want to stake your life on it, kind of thing, because it's wrong, and it's going to show up, and you're going to be forced to do silly things like Huygens and dark matter and dark energy. You're going to start inventing crap to prop your building up because you're going to see it leaning, and you're going to try to fix it with bullshit, and eventually you're just going to invent God and say, God, fix it. Unicorns, elves, fairies. You're just going to keep resorting to sillier and sillier things. I mean, dark matter is not much better than saying Tinkerbell did it.
Really? Einstein's work grew out of a remarkable shift in physics during the 19th century. It's a shift of thinking from thinking about forces between particles to thinking about fields in space.
Right. and it's a bunch of, it's just very wrong thinking. So you went from something rational. Okay, the idea that something, if I want to affect somebody, I throw an apple at your head. Okay, I have to throw the apple at your head. I have to throw it right, I have to aim it right, and it has to hit you in the head. I can't just say, well, there's a probability, I'll just let go of the apple, and there's a probability that on its own it'll fly into your head. I mean, I can do silly stuff like that, but there's no point in doing that. So we went from some physical world where real things had to travel somewhere, they had to do it by these rules, to this idea of a field that now all of a sudden it's not the thing traveling, no, it's the field telling the thing where to travel. And it's a fundamental mistake. But if you understand the kinetic field, if you understand the field is a thing in the sense that there's a ton of this stuff moving, and it's kinetic, and everything's interacting all the time, and there's only specific interactions that can cause change. So if you change polarization or you change frequency of something, then you can have effects, but you can only have effects when you cause change, and the rest of the interactions are all kinetic, pure kinetic, which means the difference between the event happening and the event looking like it happened, just missing, is going to be identical. There's no real change. It's the 2 steel balls hitting each other. No difference if you think of them going through each other or you think of them bouncing off each other. The product universe is exactly the same.
This shift introduced new ideas that extended physics beyond Newton's mechanics.
Well, let's just say beyond cause and effect. You just loosened the grip of cause and effect and started putting things in Heisenberg no man's land.
And these new ideas were powerful and very successful. But
yeah, well, again, the Leaning Tower Pizza guys, I'm sure when they were building that thing, they were saying, we're doing really well, we're really successful. And, you know, it wasn't until they got high enough they figured out the whole thing's going sideways.
But they also introduced some profound puzzles of their own. So consider an example of gravity in action. A planet orbiting the sun. Here's what we said. We said the planet is steered by a gravitational force exerted by the sun.
Right, so again, this is the typical example. So turn the sun off just so it doesn't confuse anything because it's creating light and shadows. And just understand that the force is everywhere. And that these two bodies are just going to end up shadowing a certain percentage of the force from each other. They will obscure perfect absorption of the force. The Earth can't absorb the force from the entire universe because this thing is in the way. And the sun can't do the same because this thing's in the way. It's eating part of the energy coming at the sun. Everything's heading right for it, so to speak. At every location in a pressure field, it feels like everything's heading right for you. In every location, there's places where things are just heading right for you. It's a pressure field. And these two things are blocking that pressure, and because it's a straight line force, it can't fill the voids. So that shadow is hard and real, and yeah, they're pushed together. There's no attraction. They're pushed into each other. If I have to use push or pull, I'm saying it's technically not a push because it's an absorption of acceleration, but it's push, not pull. It's from the outside in, not from the inside out.
That is, the planet gets its marching orders, so to speak, from the sun. To use the phrase coined by physicist John Wheeler, whom we will meet later in the course. But in fact, the Newtonian picture is actually much more than that. The planet gets its marching orders instantaneously from everywhere in the universe, since everything everywhere exerts some gravity.
Well, again, and none of it's instantaneous. So, yeah, look, the fact that Newton didn't know there was a speed limit has nothing to do with Newton's theories. And clearly, the fact that there is a speed limit, that the speed limit is the same for light, should make it understood that light is just a manifestation of force. It's one of the manifestations we can see. It impacts our electrons. It accelerates them. It causes an effect that we can recognize, where the gravity doesn't have the same effect. The unpolarized, unfrequencied gravity doesn't have as significant an impact.
Gravitational force on the planet. This idea is known as action at a distance.
Right, key. So this is one of these key kind of things, action at a distance. It's not really action at a distance. If I throw an apple at your head, you're not going to call it action at a distance. You're going to understand that I generated energy and I propelled something. The propellant went there and the propellant caused an effect on you. I propelled something, and that's what these fields are. The fields are full of something being propelled. And it's, again, the argument is that it's the absence of balance, no more equilibrium in the propellant that you're really doing, that's really moving the apple. So it's not that the apple's moving because I propelled it, it's because I've actually decelerated it in your direction, in the opposite direction. I've caused deceleration in the opposite direction, which causes acceleration in the other direction. I've change the equilibrium. But I have to take away force in a sense. I have to take away the thing in the way, not add. So it's all subtraction.
The sun over there somehow exerts a force that acts on the planet over here.
Right, and so the sun over there isn't exerting a force, it's blocking a force. By blocking a force is the same thing as exerting a force, because I'm destroying your equilibrium. When I block the force coming from this side, obviously the force from this side continues, you get pushed. That's a simplistic description, but that's what's happening.
Even Newton thought this was a weird and disturbing idea. Here's a paraphrase of what he had to say about it. He said, I describe gravity, but I do not explain it. And as a philosophical matter, it does seem absurd to me that one body could exert a force on another body far away with nothing between them to convey that influence.
Right. And again, I would argue that there is absolutely nothing between them in the sense that there's actually a degrade in the in-between. It is the force on the outside that's the force you can't see, but it's there. We can test for its existence by just holding anything and dropping it, and you just saw what the force is capable of. But it's, again, it's a lack of acceleration in this direction. The Earth is blocking the acceleration. It used it up, so to speak. The atoms, the electrons in the Earth ate the acceleration going this way, some percentage of them, and this didn't receive them on this side. It destroys the equilibrium, and the external force wins. Really simple.
But Newton had no idea how that influence is really conveyed.
Right, and you know, I suppose you could ponder it for. There's some things you could just ponder and ponder and ponder and say I can't, and then somebody tells you the answer and you say, oh fuck, it's just so obvious. So Lesage gravity was proposed to Newton, but again it was the ether problem. They didn't. It wasn't presented as a kinetic interaction, that is, one with no friction, one with no waste, one with no subdivision of energy. So if you think of it as ultramundane in the sense of kinetic, and that all interactions are complete, they all happen at the speed of light, there's no slower or faster. If you understand it like a school of fish, I mean, see, they could be that simple. But yeah, the school moves because the fish move. The fish go where the school goes. The school follows the fish. The school doesn't drag the fish. The fish go there, not the school.
In the early 19th century, an alternative point of view emerged. The idea arose in connection with electric and magnetic forces. These are long-range interactions, like gravity.
Right, and they move at the speed of light. So all of them move at the speed of light, gravity, and the EMF of electromagnetism. These things move at the speed of light. So again, you can make light into a complex element of field energy, or you can recognize that field energy is just a version of light, that they're all the same thing. They're just different versions of the same thing, subtle differences. This versus this, polarized, the shape, a frisbee. The frisbee can fly this way, the frisbee can fly this way. And frequency. You have a frisbee here, you have a frisbee here, you have a frisbee here. Set distances between them, that's their wavelength. That's the frequency. The frequency isn't in the frisbee, the frequency is in the distance between the frisbees. That's simple.
Electric charges, positive or negative, exert electric forces on each other. Moving charges, electric currents, exert magnetic forces on each other.
Well, let's understand, the forces are all the same. It's just whether you're a conductor or you're not a conductor, whether you have electricity. So it's just a conversion of movement. So all acceleration causes this perpendicular release of polarization for what's called charged elements, or electrons is the key thing. So you accelerate an electron, you'll create perpendicular to the acceleration, you will create a release of this gravity, photon, quanton, whatever you want to call it, the stuff moving the speed of light. So the stuff moving the speed of light is radiated from moving charges. And yeah, that's probably enough for right now.
And at first, it looks like more of the same action at a distance. But the English physicist Michael Faraday had a different idea.
So we're talking about 1867, okay? So I mean, this is really, really old. He died in 1867. I mean, this is really old stuff. And, you know, I'm not saying he wasn't brilliant, but I'm just saying we shouldn't be writing that kind of crap in stone.
He said there are electric and magnetic fields in space.
Yeah, right. So is modern physics saying that there are these actual fields? There's an actual superstructure. There's a matrix of grid work of some kind, of strings, of mechanical pieces that are going to convey this movement through them, pipes, however you want to call it. You know, I'm just going to argue that that's, again, you can go left or you can go right. You can say there's a superstructure conveying something, or you can just say it's baseballs. And they're flat. So, you know, like a frisbee. But they got one speed, and yeah, if you throw them a bunch of baseballs at the same rate, the frequency will decide whether it's intense light. Blue light is many baseballs, short distance between them. Red light is fewer baseballs, longer distance between them. Wow. I think that's the more... I just think it's the simpler Occam's razor answer to the question.
So, what is the electric field? Well, at every point in space, even empty space, the electric field is present.
Alright, so let's just argue. So what he's going to get to eventually is Einstein is just doing this to gravity. So he's making gravity field. So he's doing the same thing as this. So instead of a magnetic, electric, and now a gravitational field. So we have these three different mechanisms between everything, you know, through the whole universe, and everything is a vibration through that medium. So they're just recreating the ether, and they're just going to try to do it in some way that doesn't cause friction. And so the same reason they destroyed particle gravity, they're going to evade to preserve this matrix system of conveying energy. And it's just totally unnecessary. So at every point in space, the electric field is present. Let's just change that to the gravitational field is present. And that's the truth I'm arguing here. So that when something's in empty space, the more empty I can make the space around this pill bottle, the more energy it's actually absorbing. The more activity, in the sense that it's jostled. It's accelerating in all directions. Accelerating up, decelerating, accelerating, decelerating, accelerating, decelerating. Constantly accelerating and decelerating. So its fastest speed is achieved in the when it looks like it's going the slowest, because that's what happens to matter. Matter is, remember, matter is like that sun radiating. It's radiating. It has elements moving in all directions all the time. It has mass in all the directions because it has bits still moving in all directions. It's light trapped in this form. and the light's going in all directions and all dimensions, and that's why we call it matter, because it has mass in all the dimensions, where light only has mass in the direction it's going.
And each point in space,
And gravity and magnetism, they all only have mass in the direction they're moving.
that field has a certain strength and a certain direction.
Okay, so again, I could just make the argument, if I throw the baseball, okay, that you could just call every location of the baseball's travel a field location, and you could say at every one of the locations of the baseball it has a different kind of velocity. Its velocity will deteriorate over time. We know that's going to happen through friction with the atmosphere, and gravity is going to absorb its capacity to keep flying. Now, if you throw it hard enough, it'll just get into a perpetual orbit and go around and around forever and all that kind of crap. But if there's no atmosphere. So, but I don't need any grid work to do that. I can do it with a baseball. Why the complex answer? Do you really want to think that baseballs don't fly from the pitcher's hand to the catcher's glove? That really the baseball's a vibration through a magnetic superstructure, an electric superstructure, and a gravitational superstructure? I mean, in a sense it is, in the sense that the field is all these tiny little quanta things moving the speed of light. But the point really is the thing doesn't radiate anything. The field moves because the field is a thing. Light is a thing. It just has mass in one dimension. So it's only a thing in the dimension it's going. It's only a thing where it's going to land. It has no thingness anywhere else. Unlike the baseball, I can't see it travel because it has no profile. It has no perpendicular reality.
The field might vary from place to place. It might be changing with time.
Well, it wouldn't do any of those things unless there's a baseball. It won't do any of those things unless something blocks field pressure, unless something changes the number of baseballs flying, or the frisbees. A bunch of frisbees come out this way instead of randomly in all these different directions. They all come out one way. That's the only way the field changes. You have to change the stuff moving in the field. And the stuff moving in the field obviously moves the speed of light. It's obviously a thing. It takes time to move.
Electric charges are the so-called sources of the field. That is to say, they determine the field values everywhere in the universe.
Right, but it's not the charges themselves, it's the acceleration of the charges. So again, you have to accelerate them for them to change the fields. And they're not changing the fields, they're shooting frisbees. They're converting frisbees that are going in all these directions, and they're shooting them all out going this way. And then they just happen to be shooting them at matter that has grid work going exactly the opposite way, and so the frisbees have more of an impact.
And we could map out the strength.
I mean, I can argue this. I've already explained this polarization argument, but you could understand that if matter creates filters, bars, and those bars are what you're throwing your frisbee at. Obviously, if I throw all the frisbees on end, they'll go through straight line bars, but they won't go through horizontal bars, and vice versa. And that's the nature of matter. Matter is a polarizing filter.
And direction of the electric field in space. So, given that the field exists, the electric force on any particular charge is completely determined by the field where the charge is.
Right, so it's just basically saying it's like the gravity argument. If I take one thing and then I have another thing and they have a gravitational interaction, well, if I put a third thing and then a fourth thing and a fifth thing, now these are all interactions. So yes, obviously this thing is going to be affected by all these other things radiating gravity, right? And what really we're talking about is blocking or shadowing. So the shadows get kind of complicated, but the shadows are real. The shadows are going to cause acceleration towards the low pressure. So the low pressure changes as you put more elements in the field. But the conveyance of that force is through a real mechanism, real stuff with real properties moving the speed of light. It's not a medium explicitly. We're the medium, and the medium is quanta moving the speed of light. The medium is basically gravity, gravitons, random polarization, all moving the speed of light without frequency. And when you apply frequency and polarization, you get light. When you apply polarization, you get magnetism.
That is, an electrically charged particle gets its marching orders locally.
Well, again, it's always going to be local. I mean, it's kind of silly to say it's local. I can put another planet in the solar system, and it's going to affect our movement through the solar system. Clearly, I'm only going to move because of the amount of the light that comes from it, the amount of the gravity I receive, or the absence of the shadow. The depth of the shadow will decide. But the depth of the shadow will be moving me, and the shadow did have a source. So if my cast shadow causes the ground to do something, okay, it's stupid to say the ground only did it locally. Well, it did it because I cast the shadow.
Locally from the field at the point where the charge itself is. So we can express this as an equation. Let's suppose the local value of the electric field is E, and we put an electric charge Q in the field at that point. Then the force F experienced by the charge is given by F equals Q times E.
Right, and this just has to do with what your Q is, whether it's a positive or a negative. So the positives will repel, the negatives will attract. But again, this is the matter converting, okay, that if this was a gravity argument, okay, then you could sort of understand that it's just going to be the stronger, closer wins. Whatever the r squared value that's different, the closer one's going to win. In this argument, it's going to be more about the polarization argument. So this side, if this was negative, this is producing negative. This one's sensitive to negative. Negative pushes it. Okay, it's invisible to the positive. It's visible to the negative. So it'll be pushed by the thing it can see, that the filter, it hits the frisbees hit the bars. And the other side, the frisbees are going right through the bars. So on this side, the frisbees are going through. This side, the frisbees are getting blocked, and the charge is going to go where it blocks. So you can see that this instantly causes repulsion and attraction, in the sense that the like charges end up repelling because this filter's already filtered all of the stuff to be exactly the thing it's sensitive to. It's got horizontal bars. It's now polarized everything vertical. They're guaranteed to hit the horizontal bars, that kind of argument.
This means that the same field can affect different particles in different ways. A positive charge is pushed in the same direction as E. A negative charge is pushed in the opposite direction. And a neutral particle, one with Q equal to 0, experiences no force at all.
Yeah, this one I'm not quite sure of, the neutral charge idea. I think it's more of a, this is the half, this is the 1, so you got 1, half, and then 0. No, 0, 1, and the neutral would be the half. Something like that.
So we can see
it's both positive. It's like a magnet. It has a positive and a negative side, and so it will, if it can't flip, it'll stay neutral because it has an equal amount of effect from either side. But it's being affected, it's not a nothing.
See the effect of the field when we see charges pushed this way or that. But the field exists in space. Even if
So the field exists in space. Again, so the superstructure exists, where, again, I would argue that the superstructure is just the quantum moving. And yes, we're changing their color in the sense that we're changing their character, the polarization, a feature of them. And when we change their polarization at exact locations in a stream, those exact locations become a frequency recognized by the same polarization. So every ray, every beam of light has rays of light in it, and those rays of light have all the same polarization, and that's what makes it identifiable as a ray of light.
no charges happen to be present. Okay, let's sum it up. Charges tell the field how to arrange itself in space.
Okay, charges tell the field how to arrange itself in space. That's not happening. Clearly the field is in control. The field is, and all you're really doing is filtering elements of the field and throwing at other filters what you filtered. So I filter frisbees, you are affected based on what you're sensitive to certain frisbees, and that's all that's really happening. I'm just changing the character of things that are inevitably going to take their course. There's no momentum change in the universe. The only thing that changes is the identity of the things, the character of them, not where they're going, not the speed they're traveling. That never changes because it's all kinetic. And the only thing that's changing is like the color of the car. The two cars collide, and instead of the blue car going through the red car, a red car collides into a blue car, and instead of like the kinetic balls, the red going through and the blue going through, the blue bounces off and the red bounces off, in the sense that the one going this way gets its color converted from blue to red, the one going this way gets converted from red to blue.
Then the field tells charges how to move through space.
Well, tells them, this is not very good physics when you start talking about things telling something else and then somehow it understands and it acts and all of that kind of crap. You have to explain this as a force, okay? There's things pushing things, and that's all there is. Things get pushed. I hate to make it that simple, and they're not getting pushed. Oh, they're getting converted. Things get converted, and that's all this is. The physics is conversion, and all you're converting is polarization ultimately. All structure that we identify in the universe is just a conversion of polarization, but to give it identity. But the real truth is that these things travel at a set speed. These changes, these conversions, happen by rules, and the result has to travel the field speed, which is the speed of light. That's the important thing to say. The field speed is the speed of light, and you're made of field. You're moving the speed. Your bits are all moving the speed of light. Nothing moves any other speed. There's only fish. We're schools of fish. Our fish, their speed is fixed. Their speed is constant. They can't change. All we're changing is what fish are in the school. Fish going this way or fish going that way. That's all it's changing.
And that's Faraday's big idea. And magnetic fields and forces work out pretty much the same way.
Right. Well, they're both, it's like I said, it's the same field. And you're just talking about the effect on electrons. So in conductors, the acceleration of electrons and creates electricity, what we call electricity. But it's just acceleration of electrons. And the same thing is happening in magnetism. It just has to do with the electrons and the filter they're creating. Yeah, it's the same filter. One's created by a magnet, one's created by a moving electron. Which you could argue the electrons are always moving, and in magnetism they're moving in a ordered way that creates the same field, perpendicular field energy. Okay, something like that. But anyway, out of time, I'm pretty sure. Camera's getting warm, battery's almost dead, so we'll call it a video and continue probably to finish eventually. But I think it's purposeful. So till the next installment and such.